Wow, here we are. These are samples from all the micro and nano lots that we produce at Finca La Mula and Finca La Cabra in Panama. And you can see it's a great number of samples. I have a lot of work ahead of me. And so in total we have here about 50, 60 samples. And there's specific steps required to now do the work. So you can imagine this is a lot of work. We have natural process, I have traditional washed process, I have more experimental wash, which is a combination of anaerobic fermentation with washed, and then I have the more traditional natural process. So all these different processes with these different varieties, because we have geisha, then we have the AF1 TG1 variety, we call it TG1 to our clients, and then we have AF2 Betty 2. Betty 2 is the name for our clients. So these are very distinct heirloom Ethiopian-like varieties. So I would like to show you the steps that I follow to inspect my green coffee, to inspect the moisture, to also inspect the water activity, and kind of to show you how I'm doing the physical and sensory inspection of the coffee. So I have various tools here. These types of cards are always very, very handy. They allow me to keep track of what the coffee is, obviously. Then these sample trays that you can buy online from different merchants. Very handy also, partially also because you can bend these sample trays so you can pour the coffee in whatever other bag or basket you have. And then some tools that I have here. Here on this side, here's a moisture analyzer made by a company called Shore here in the US. It's a moisture analyzer, plus it also allows me to measure the density of the coffee. I'm going to show you that also, how that works. Then here I have an extra scale, and then this is my water activity meter. And then here I have a black grading mat that you can buy from the SCA that helps you to really grade the coffees. And then here I have a special light with also a magnifier that allows me to look at the coffee up close. So first, what do I look for when it comes to the physical properties of the coffee? Of course, I can do like a grading exercise, and if you want to learn about grading, you can do that as one of our courses, or you can do this also at any other SCA course or Q course. Grading also includes smelling the fragrance of the coffee to basically assess whether the coffee is clean or not clean, and I also use this for assessing the color. And the color is really important also it gives you an idea of what the age of the coffee could be. This is a micro lot from La Mula. You can kind of see that this coffee is very clean. It's a washed coffee. It has kind of a light olive color. This coffee is also a coffee from one of our farms, from Finca La Cabra. Here I'll show you the beans. And this is a natural processed coffee. It's an Ethiopian heirloom. Now let me show you how the moisture analysis works. This moisture analyzer, as often they require a very specific amount of coffee. So I place my tray here. This moisture analyzer requires 250 grams. So let's weigh that out. And then when I'm going to measure the moisture, I want to find a moisture that is ideally between 10 and 11.5%. SCA says up to 12%. We prefer here 11.5%. That's what we do in our farms also. So I pour the sample in here. I load the sample in the moisture analyzer and I say test. And now it will give me, it does a calculation, 11.8%. And I always like to do multiple measurements because these moisture analyzers have a kind of a margin for error. So I engage this again and I get the machine ready. It calibrates. This is a self-calibrating moisture analyzer. I load it up. These moisture analyzers work by the concept of measuring water activity, and then it runs through a sort of algorithm and it calculates the moisture. 11.8%. One more measurement. And I get the machine ready. And what will it probably say? 11.9%. So we can conclude that the moisture is somewhere around 11.82%, something like that. So now I know that my sample is in the right ballpark. I'm going to write this moisture percentage down on my handy card. 11.81%. What I also can do with this same machine, and this is relevant for roasting also, I can also measure the density of the coffee. And why is density important? Because coffees with more density can hold more heat, they can sustain more heat, and they can often benefit from a little bit more heat. And even when we're doing sample roasting, that really helps to know. So now I get my device ready. For this purpose, I'm going to fill this volume. This volume is precisely defined to work with this machine, and it will allow me to make a measurement of the density in kilograms per hectoliter. 1 hectoliter is 100 liters, so it will basically measure how many kilograms I can fit in this volume that is, in this case, this small volume, but it calculates it into hectoliters. So you can see the steps I follow. Now I place this beaker back on the moisture analyzer, and it tells me 70.2 kilograms per hectoliter. And that's very consistent with what I measured before. Before it was 70.1. So that gives me one measurement. And now I can measure this other sample. And I already did that before we recorded this episode. And this sample measures that's the La Mula at 71.7 kilograms per hectoliter. So there's a bit of a difference there. What causes that difference is the fact that this coffee, La Mula, is grown 250 meters higher on the same mountain though. So that's really interesting. It's also of a different variety. Now, I'm just going to shove this to the side just to show you what I'm doing also in terms of assessment of color. And now I have this special lamp here. And that helps me, this lamp helps me to gauge the color on top of the black mat. And here in this lab we also have a ideal intensity of color to be able to see the colors of these beans really well. And here I can see, now I can get a more true impression of what beans I'm dealing with. And also, if I want to do a grading exercise, I could do it right here on the spot. Now, finally, as part of this exercise, I want to show you this concept of water activity. So what is water activity? And I'm getting my little device ready. Water activity is basically the way in which the moisture inside the green bean is held and the way in which it is dynamic, whether or not it has the tendency to migrate or not. The ideal ranges for water activity are between 0.6 down to 0.45, as the literature tells. It is very important to have a well-calibrated water activity meter. So we have done this calibration already, of course. So now I feed the sample here in this beaker. And I always make sure that I keep my sample labeled wherever I place it. Now I place the lid with the probe in this beaker, and now the water activity meter is doing its work. These measurements can take a little bit of time, so it's not like it immediately gives you a measurement, because it very gradually measures the water activity. Also, to some degree, to some form of water conductivity measurement, but also it runs it through an algorithm then. And right now the water activity is 0.54. When I tested this water activity of this specific coffee, it settled out at 0.55, which is a little bit higher than what the ideal range would be, which is 0.5. So what does it mean? If you have a water activity that's relatively high, higher than 0.6, then the shelf life of that coffee might be not as long as you would want it. So typically a water activity level of higher than 0.6 could result in your coffee deteriorating in quality within 6 to 7 months. And so if it's lower, if it's like 0.5 or 0.45, then that same coffee could be much more stable in quality over a much longer time. So that's really interesting. So again, moisture between 10 to 11.5%, water activity ideally around 0.5, and then the color needs to be free of odors. So these measurements are essential, and they give me a good set of data before I get my hands on the sample roasting. All right, so now it's time to do roasting. I've been cleaning my WPG1A very thoroughly. These are my babies, so I want to do this sample roasting at the best of my abilities. I've been deep cleaning the machine. I've been preheating the machine. So what I do when I'm roasting samples, and I have such a large number of samples, then I'm using the thermostat of the machine. So that's basically the device that helps me to maintain a consistent temperature in the machine. I'm first going to roast the TG1 coffee. That's a natural process coffee. That's the African heirloom. I have 100 grams, and so I am going to get this roast going, start my timer here on my panel, and then I'm just loading the coffee. The burner is in automat, and then the thermostat is at 350 degrees Fahrenheit. Here you can see my settings. I'm keeping the thermostat at 350 degrees Fahrenheit. And now, until the rate of rise starts to even out, then I will start increasing my thermostat temperature, as a result of which automatically my burner will facilitate that heat that I'm asking for. And so now we are almost there, and now I'm going to set this at 385, oh, that's too far, 385 degrees. And in terms of my air pressure, I'm keeping this at 90 Pascal right now. I'm going to increase it when we are going into the Maillard reactions. And that hopefully helps you understand a little bit how I'm strategizing these roasts. So what am I looking for at this stage? I'm just monitoring the bean temperature, 228 degrees Fahrenheit. That means at that temperature level, the Maillard reactions will start ramping up quite soon. Now, for this coffee, remember we measured the moisture and we measured the water activity. Here the water activity was kind of high, 0.57, and the moisture was also kind of high, 11.8. So I want to really not push this roast too much. So that's why I'm not bringing the heat, the thermostat setting up higher than 385 degrees right now. My rate of rise is 14.5, so that is 14.5 degrees per 30 seconds. So this is a relatively linear roasting curve that I'm following. Let's see where we are. I'm going to show you. You can see that the beans are picking up some color. And that is also indicative of the Maillard reactions. The La Mula will be a different story because that coffee had a moisture of 10.9% with a water activity of 0.44, which is on the low side. And so the La Mula, we can actually give it a bit more heat. That means somewhat more heat in the beginning, and then also allowing the heat in the drum to rise up to 395 instead of 385, which we are doing now. So you can see that's the beauty of the WPG1A Giesen, is that I can very much allow these samples to roast kind of in a not an autopilot, but in a semi-automatic pilot setting. And then here you can see the beans. I hope you can see that somewhat well. And we are now 4 minutes 48. My bean temperature is 305 degrees Fahrenheit. My rate of rise has come down a little bit to 9.8, 9.7. So this is kind of an ideal example where I have to do relatively little manipulation because I allow the machine and the settings I chose, given the parameters, do its work. And that's the beauty. First crack is starting. 5 minutes, 30 seconds. Yeah, that was just an incidental pop. Now I do hear a first crack, yeah. So I'm going to bring my temperature setting, my thermostat setting down, because I want to bring the rate of rise down of the coffee as well. And I'm setting now my thermostat setting at 365. And here is, and I don't know if you can see these colors of these beans. And now I let these beans here in my cooling tray. 6 minutes, 7 minute roast. Somewhat on the fast side, but overall a good level of development without necessarily losing control. Ramping up slowly in order to allow the relatively high moisture and the relatively high water activity to balance out. And so this is an example of how you can let the parameters of the coffee do its work, help you set the course. Next, we will be roasting the La Mula, which is a much denser coffee, and which will be interesting to follow. So now we did the first sample, the TG1 natural process. Now I have the La Mula wash process, and the La Mula has lower moisture. It has also a lower water activity, so it's all more stabilized, the water content in this coffee, and it's a denser bean. So because of that, I have decided to again use my thermostat setting of my machine. Now I'm starting at an environmental temperature of 365 degrees. So that's what I have set my thermostat to be. I keep my PA at 90 at this stage, and I have to start my timer, of course. Time is running. So what I'm doing now is I'm allowing these beans to start roasting in a higher environmental temperature. And this coffee is grown 250 meters higher than the first coffee we roasted. Why is elevation preferable? It's, simply said, if you grow the coffee higher, the cherries will need more time to mature. The process of what we call cellular respiration and the corresponding Krebs cycle evolves slower. As a result of that, usually you can find a more complex and a higher volume of specific oils, and also the acidity levels, citric, malic, phosphoric acidity can be more pronounced, more vibrant, and that's we can of course taste in the cup. But we can also taste or measure the density, and the La Mula tested out 2.3% higher in density than the Finca La Cabra TG1. So that also justifies the fact that I can use a slightly higher temperature. The only thing is, I of course need to make sure that I'm not going to allow this process to go too fast. So now we've gone through the rate of rise. The rate of rise is now positive. Now I'm going to push up my temperature, my thermostat setting to 395 degrees. I'm allowing that to stay in place until we are well progressed into the Maillard reactions, which is around 300 degrees Fahrenheit bean temperature, and then I will bring it down. And if you just want to hear this from me in simple terms, then for higher moisture coffees, where often also the water activity is higher, use a much slower initial beginning of heat application. For coffees that have a moisture content of around 10.5 and that have a ideal water activity, these beans, especially when they have more density, then they can endure, they will profit, they will be benefit from more heat. And that's how you can approach your sample roasting. So here you can see my thermostat I've now adjusted to 386. My rate of rise is 10.2. Bean temperature 318. In about 10 degrees I will have the start of the first crack. So I'm actually going to adjust this one more to slow down the process significantly. Okay, now my bean temperature is 329. First crack is already starting very early. Going to bring down my thermostat setting more. First crack is at 5 minutes 30 seconds. And I'm bringing down my thermostat all the way down so that I'm going to finish this roast, to try to finish this with the heat that the beans have been developing, kind of that kinetic heat. Of course, I need to ensure that the roast is not going to stall. This is where we are. Very close to releasing this coffee. Wow. 6 minutes, 30 seconds. Make sure my cooler is on. Yeah. So I was a little bit afraid for a moment that I was going too fast, too hot, but I think we've accomplished a really great roast. I'm going to compare with you the final results once this is cooled down. So now we have roasted the samples. Now I can do my final inspection on visual color. The La Mula seems to be a tiny little bit darker. I've done the measurement using my color meter also. The La Mula was 57.8 and the La Cabra was 58.1, so they're very close. And now I have shown you, I think, in this episode, the steps you can follow to really diligently inspect your samples, to collect data, to understand what the coffee is all about. And I hope you can do your benefit with that. Good luck, and we will see each other soon again.